Shocker. Airplanes don't take off with the wind, but actually against it. I'd think that if you take off with the wind, it pushes you forwards and helps you fly faster, but this is wrong. So I did some digging for us. We should think of an airplane as a kind of kite. To make a kite fly, you launch it against the wind, and so it flies. Here's how it works. There are 4 forces of flight: lift, weight, thrust, and drag. The lifting force is generated because of the differences above and below the kite. Above the kite, the speed of air is higher than below it. So, the pressure below is higher than that of the pressure above, and the kite is pushed forwards. This is the lifting force. There's also an opposing force, the force generated by gravitation that pushes the object down. That one is called weight. The thrust is the force that pushes the object forward. In the case of a kite, it's generated by the string, the wind, and the forward motion you're making. In the case of an airplane, the thrust force is generated by the engines. Finally, drag is the opposing force of thrust. So, to launch a kite into the air, the lifting force must be greater than that of the force of weight. Then, to stay in the air, all 4 must stay in balance. Lift must be equal to weight, thrust must be equal to drag. The moment the plane takes off, going against the wind helps to generate the needed lifting force faster. Yes, going against the wind does decrease the ground speed of an aircraft, but that's not the speed we need. An airplane flies due to the speed of air flowing over the wings. This airflow isn't generated by the plane's engines, but by the wind. And the higher the airflow, the higher the lift. Going against the wind increases the flow of air over the aircraft's wings, giving it an additional lift and allowing it to achieve a higher altitude in less time, because it takes off at a greater angle. The same works for landing. Landing against the wind lets a pilot to descend at a shorter distance in a shorter time. The airflow and the lifting force are the things that are responsible for turbulence. The direction and speed of the wind, and therefore the airflow, isn't constant over time. Sometimes it changes pretty quickly, like 100 times per second. So one moment there's more lift, and the other moment there's less lift, and then the plane is shaking. This is called the turbulence zone. It's not dangerous at all. It just means that you fly through the zone of highly constant wind, and that's all. So if a pilot is given the option of how to take off, they'd pick to take off into the wind. It's not always the case, and it's not a problem taking off with the wind, but going into it helps a lot. Many airports are designed so that most runways are taking the direction opposing the most typical wind direction of the area. Also, taking off and landing are the most dangerous stages of any flight. That's because the pilot has less time and space to react to any occurring problems. In the air, even if both engines stopped working, a plane won't just start falling. Instead, it'll start gliding through the sky, losing about 1 mile of altitude for every 10 of them going forward. So, the pilot will have about 8 minutes to react and find a safe place to land. During takeoff and landing, the time is limited. If an engine fails, the pilot will have seconds to decide if they should still take off and deal with the problems in the air or cancel the flight. The thing is that canceling isn't even always possible, even if something happens. If the plane has already reached a speed of 100 miles per hour, it can't possibly be stopped before the runway ends. Physics. And getting out of the runway isn't good. Flying is costly, so not only the passengers, but the airline as well wants to make the flight as fast and short as possible. So there's no surprise here, there's always the most efficient way to go from point A to point B. And the shortest way is, of course, a straight line. Now, look at some aircraft routes. These don't exactly look straight, but don't let this trick you. We have to keep in mind that the Earth isn't flat like we see on a map. It's a sphere. So these lines only appear like arcs when we project them on a map. In reality, they're pretty much straight. If there's an efficient way, this means that every airline and every plane wants to fly this way. But there are hundreds of planes going from North America to Europe every day, and many go at the same time. Turns out, the air highway is pretty busy. So how come the planes never collide? That's because before a flight starts, the crew make a strict flight plan that is uploaded to the aircraft's computer, and that pilot will have to follow. To be completely honest, there are several of them, just to have options if something goes wrong. What helps to avoid any colliding is that the airspace is three-dimensional, and the planes don't only fly in several lines as cars, but also at different altitudes. Air traffic is managed by dispatchers who watch for planes and control that they don't get closer to each other than 3 miles. There's also flight level regulations. All the westbound flights fly at even-numbered altitudes, like for example 34,000 feet or 36,000 feet, and all eastbound flights fly at odd-number altitudes, like 35,000 feet and 37,000 feet. This means that there's a couple of thousand feet between the planes flying in the same direction. To share the sky safely, each aircraft has to follow their own airway that even has a specific name. There are also some parts of the air that are especially busy, having remarkably high traffic because many planes fly there every minute. So, whenever an aircraft enters a busy zone, it has to stick to a very specific route. So, usually, commercial aircrafts fly on the altitude between 31,000 and 38,000 feet. This altitude is reached within the first 10 minutes of the flight. So, why so high? With height, the air gets thinner, so the plane faces less resistance and can fly faster and burn less fuel. Another reason that they fly so high is that the plane avoids most of the weather patterns that usually happen way lower. High winds and rain happen in the troposphere, the atmospheric layer that is closest to the ground. Planes fly just a little bit above, but already in the next layer, the stratosphere. Since most of the weather phenomena are avoided, the flight is smoother and there's less turbulence. But then, why don't they fly even higher? Remember the force of weight that pushes the object down. An aircraft is very heavy, and the more you weigh, the harder it is to get higher, because the force is stronger. To push it even higher, more fuel will be needed, and that's inefficient. Also, the oxygen becomes too sparse to fuel the engines, so the planes usually fly the most efficient way. High enough to avoid the weather patterns, but not much higher so that they don't spend too much fuel. If you've ever flown, you've probably noticed those little holes on the windows. An airplane window has 3 panes of plexiglass. That tiny hole is only in the one that's in the middle. It exists to regulate the huge pressure difference inside and outside the cabin. This way, the outer plane can handle the load. If the outer pane breaks, the middle one will keep the window intact. Also, that hole also keeps the windows from fogging up. Have you noticed that whenever you enter